Hey class, welcome back. Today we're looking at 14.1 part 2. So we're finding limits using graphs this time. So this lesson is going to be pretty fast because you're given the graphs and we're just trying to identify the limits here. So like we said last time, if we're allowed to substitute, we can substitute to find our limit. So let's just go ahead and do that for this first one. We're looking at limit as x approaches 0 of 3x plus 5. So if we plug a 0 in for x, it's not going to break any rules here. We're just going to multiply 3 times 0 and add 5. So if we did that, we'd get 3 times 0 plus 5, and then 3 times 0 is 0. 0 plus 5 is 5. So the limit here would be 5. Now let's look at what that would look like if we're to graph it. All right, so let's put our axes up here. Okay, so if we're doing this in slope-intercept form, then we know our y-intercept is 5. 1, 2, 3, 4, 5. And then our slope is 3, so it would look kind of like this. Let's draw a straight line here if I can. It's not too bad. All right, so the limit as x approaches 0. So let's look at what that means graphically. So if I approach 0 from the left side, and I approach 0 from the right side and then from the left side, what I get is this value here. And you can see that definitely the value as we approach 0, right, because this is 0 for our x-axis, is going to be equal to 1, 2, 3, 4, 5, which makes sense. That's our y-intercept. So the value here at 0 is 5. So the limit would be your y technically, right? And then obviously your x is going to be 0. Okay, so just graphically what finding the limit looks like. Okay, the second one, this one is a piecewise function. It's not a really difficult one. But yeah, so we're going to see if we plugged in 2 here, 2 would fall into this category, right? If x equals 2, then we'd have 3. Now notice this is the case where if we plug in to our function, we're going to actually get a different answer from the actual limit. So let's go ahead and graph this one, and you can kind of see, hopefully you can understand why it means that the limit is not always the actual value. Especially for these piecewise ones, those are the ones you got to be very careful about. Okay, so if we look at our function, it's saying that when x is 2, then the value is 3. So if we have, when x is 2, right, that's our 2 on our x-axis, the actual value of our function is going to be 3. So I'm going to put that point in there first. Now, it says on the top part for this piecewise function, every place where it's not equal to 2, then it's going to look like 3x minus 2. So let's graph 3x minus 2. So negative 2 is your y-intercept. Our slope is 3. I don't know why they keep giving us such big slopes because they're kind of hard to graph. The next one would be at 2, so I'm going to put a circle here because that's the point where it's not actually going through there. I'm going to continue it. So it's kind of a bad example, but alright, let's change colors here. Let's do orange. And the thing to note here is that these don't actually, that point doesn't actually touch the line that we drew in here. Let's do a different color there too, just so we can see it. So that purple point is below the line. That hole that we have here means that we still have a function, right? It's not overlapping that purple point below it. So let's think about the limit this way, right? So the limit as we go from, let's change that color. The limit as we go from left and right is not going to be the actual value. The actual value is going to be the point. So the actual value, if we did f of 2, right, that's going to be equal to 3. Now, if we look at where it approaches, so we're following the line of the graph from left and right. We're actually approaching this value here, which is 1, 2, 3, 4. So the limit for this one is going to be 4 as opposed to 3, because we're not following the line to that point. That point is off the line, right? Everything else on the line suggests that we're going towards the value 4, even though 4 is not on our line. Okay, so that's a huge idea in limits, and you're going to build on that idea of limits from the very beginning of calculus. And the better understanding you have of limits and what they do, then it's going to be easier for you to understand how they're using limits to build this idea. And the idea is trying to find the slope from a single point. That's what they're using this limit idea to build towards. And that would be the whole first semester of calculus, finding the slope from a point. It's called the derivative. All right, so some things here to note, right? So we said that if we look at this first parabola looking graph, right, the limit we're finding is going to be the number it approaches as we go towards the left and right. So if we're looking for the limit at this particular x value, we're not taking the value of that point. We're looking for where this graph is headed, even though there's a hole right where we're looking at. Similarly for this graph here, the limit, we're headed towards this point, right? If we're finding the limit at that point, even though there's not a value there, this does have a limit, because these two lines we're tracing from the left and the right, they both converge on a single point, right? We're looking at that point right there. The left and the right hand side are going towards that same point, so it does have a limit. Now, ones like these, right? If I approach this, if we're trying to find the limit here, if I'm approaching this from the right, I have this value with the open circle. If I'm approaching it from the left, I have this value with the closed circle. These 2 points are not the same value, right? So because these are not approaching the same value, this one has no limit, right? Because the two sides don't agree. So let's kind of write that. For a limit to exist, the right and left sides must approach the same number. Okay, very important. Now, that doesn't stop us from asking, okay, what value is this? What is the limit for this if we're approaching it from the left side? Then we can definitely say, okay, if we go from the left side, then we have this value. If we approach it from the right side, then we have this value. That's okay, but overall, it does not have a limit. Similar to this one, as we approach to the left, we have this open circle that we're approaching. As we approach from the right side, we have this open circle they're approaching. Because these do not agree, they're not the same value, this one will also have no limit. Okay, so just conceptually speaking, functions where we can find limits versus functions where we can't find a limit, we gotta make sure that they approach the same value. Okay, so that's it for today. Pretty quick, but one of the big ideas that you guys will be building on in calculus. So if you have any questions, please write them down, bring them to class, and then we can discuss them next time. Good job today.